Now let's start solving the previous year question of quantum mechanics from maybe after 2014 to 2025. So what we will do, we will divide it in a section wise from basics to advanced. So first we will look into the time evolution of the state questions from this part, and here are two questions we have for from this part, which was asked for. One question were asked in 2014 and another were asked in 2016 June. So let's solve this question first. So here question 1 states that we can clearly see, let psi1 and psi2 denote the normalized eigenstates of a particle with energy eigenvalues E1 and E2. Okay, let's change the color. With E2 is greater than E1, E2 is greater than E1, it means E2 is higher state and E1 is lower state, maybe a two state system, E1 and E2. So at time t is equal to 0, the particle is prepared in a state psi t is equal to 0 is 1 upon root 2 psi 1 plus psi 2. So this is the linear combination of psi 1 plus psi 2. So at time t is equal to 0, which is mentioned here. Now, what will be the wave function for E1 and E2, state E1 and E2, or we can say the linear combination of states E1 and for the particle at psi t is equal to t. So we can write it as, so what will be the wave function? So psi t is equal to t at t is equal to t 1 upon root 2. The psi 1 state will evolve minus I E1 t upon h cat psi 1. In Dirac notation form we can write it. So using Dirac notation is very simple. Plus e to the power minus I e2 t upon h cat psi 2. Now the question is the shortest time t at which psi t will be orthogonal to psi t is equal to 0. So at what we have to do, we have to find the orthogonality condition at psi t is equal to t and psi t is equal to 0. So what will be the solution? So at what time t this wave function, evolved wave function in time, is orthogonal to the wave function at initial state t is equal to 0. So using orthogonality condition. So what is orthogonality condition? Psi I psi j is equal to delta I j, where I is equal to j normalized, and when I is not equal to j, so this is a scalar product. So what we will do, let's go and solve this question. So for psi t is equal to 0 to psi t is equal to t should be 0. So what is this 1 upon root 2 psi 1 plus psi 2? This will be in, where again for the kit notation, uh, 1 upon root 2 e to the power minus I e1 t upon h cat psi 1 plus e to the power minus I e2 t upon h cat psi 2 should be 0. So just we can take 1 upon t psi 1 e to the power minus I e1 t upon h cat psi 1 plus psi 1 e to the power minus I e2 t upon h cat psi 2 plus uh, psi 2 e to the power minus I e1 t upon h cat psi 1 plus psi 1 e to the power minus I e2 t upon h cat psi 2 okay is equal to 0. So here this can be taken out, this can be taken out, this can be taken out, this can be this part can be taken out. So this will be the, psi 1 and psi 2 is orthogonal, so this will go to 0, and psi 2 psi 1 again this part will go to 0, and psi 1 will give 1 because psi 1 is normalized function, and psi 2 psi 2 will also give 1 because it is normalized function, and 1 by 2 we can just drop down here 1 by 2. So 1 upon 2, here we will get e to the power minus I e1 t upon h cat plus e to the power minus I e2 t upon h cat is equal to 0. So we can simply write here e to the power minus I e1 t upon h cat is equal to e to the power minus I e2 t upon h cat. So we can simply write I e1 minus e2 t upon h cat is equal to minus 1. So we can simply write it in a cos and sine form. So cos e1 minus e2 t upon h cat plus I sine e1 minus e2 into t upon h cat is equal to cos 2n plus 1 pi. So from here we can relate imaginary part will be 0, this whole part is 0, so only real part will stay here. Now here we can see cos e1 minus e2 on t by h cat is equal to cos 2n plus 1 pi. So arguments should be equal, e1 minus e2 t upon h cat equal to 2n plus 1 pi. Now taking t is equal to 2n plus 1 into pi h cat by e1 minus e2. So 2n plus 1 for n is equal to 0, n is equal to 0, what we will get? t is equal to for n is equal to 0, it will be pi h cut by e1 minus e2. So let's look at the solution. What are the options? e2 minus e1 and e1 minus e2. Okay, this part is here. So the solution will be B. So just the sign will change e1 minus e2, but the solution will be the same. Now another question is, here the eigenstates corresponding to eigenvalues e1 and e2. The eigenstates corresponding to eigenvalue e1 and e2 of a time independent Hamiltonian 1 and 2. These are the time independent Hamiltonian. If t is equal to 0, the system is at the state again the same. So these are the wave functions, and this is written in the linear combination, and this is normalized because when we take psi t is equal to 0, psi t scalar product of this, then this will give sin square theta plus cos square theta, so it will be 1. So this is normalized wave function. Then the value of psi tt at the time t will be, what will be the value of sin tt at the time t? So again we have to find the time t. So what we will do, we will write psi t is equal to sin theta e to the power minus I e1 t upon h cut 1 plus cos theta e to the power minus I e2 t upon h cut 2. Again taking scalar product, psi will be what it is going to be. Let's find the solution, and states that the value of psi tt at time t will be, we can write sin theta e to the power I e1 t upon h cut 1 plus cos theta e to the power I e2 t upon h cut 2 and sin theta e to the power minus I e1 t upon h cut 1 plus cos theta e to the power minus I e1 t upon h cut 2. Now just need to solve it. So what we will get, first one will give sine square theta plus and minus, this will give just sine square theta 1 sine theta cos theta this is going to be e to the power I e1 minus e2 t by h cut, and this is constant 1 and 2, so it will give 1 2 plus again cos theta sin theta e to the power I e2 minus e1 t by h cut 2 1 plus cos square theta 2 2. This will give, this part will be 0, orthogonal, orthogonal, this is normalized, this will give 1, this is normalized, this will give 1. So the solution is, we can write it as, wait, okay, sin square theta plus cos square theta, which is equal to 1. So the solution will be this part. So we have solved two questions which is come in 2014 and 2016. So now we will move to the next topic, which will be maybe commutators next topic, and in that part we will have at least 5 to 6 questions. So thank you till now, and again just go and practice this problem. This is going to be very easy, not much is there. So thank you.